Hey, it's me, Destin. Welcome back to Smarter Every Day. So before we start the butterfly deep dive, the one question I get more than anything else here on Smarter Every Day is what's your educational background? So, figured I'd tell you. I got my bachelor's degree from the University of Alabama in mechanical engineering. And I got my master's degree at the University of Alabama in Huntsville in aerospace engineering, specifically in rocket propulsion. Anyway, so now that that's out of the way, the cool thing about this video for me is that both of my university alma maters are working together to unravel the mystery of butterfly scales. And I think that's pretty awesome. Where'd he go? Anyway, so what they're going to do is here at the ATOM lab, the Autonomous Tracking and Optical Measurements lab, there's a bunch of cameras set up and we're going to track butterflies and we're going to try to determine if they are more efficient with or without their scales. It's pretty cool. Now, if you'll excuse me, I need to go joust myself. If you're new to Smarter Every Day, a deep dive is a clickable playlist that you can check out at any point in this video and research one specific topic in great detail. For example, in the past we did a deep dive with helicopters. Look at that. Still powering this thing, and it fell out of the sky. Why is that? It's because micro air vehicles are historically inefficient flyers, which is interesting because butterflies are super duper efficient. I mean, think about it. These things can migrate thousands and thousands of miles. Dr. Amy Lang at the University of Alabama has been researching the aerodynamics of butterfly flight. And Dr. Nathan Slagers at the University of Alabama in Huntsville has a 3D facility for tracking micro air vehicles. So is there a way we can combine the two? We'll take the aerodynamic research from Dr. Lang and the ability to track a 3D vehicle by Dr. Slagers and see if we can baseline the efficiency for a butterfly and then make modifications to the butterfly in hopes of increasing the efficiency of a micro air vehicle. If we have a butterfly wing and we've marked it with a retroreflector marker on it, we can reconstruct where it is. We have cameras all over the walls over there, and if they know exactly where those markers are, you can combine all that data and figure out a 3D position of the butterfly. What does this mean? This means you can fly this butterfly in 3D space, wherever it wants to go, and then you can analyze the data after the fact. Now that's very important if you're trying to figure out efficiencies of flight. Think about this. You could fly a butterfly with scales on his wing and without scales on his wing, and you could figure out if he's more efficient or less efficient because he has scales.
Micro air vehicles, the major problem is batteries right now. People can build robo-flies like they do at Harvard, but they're powered by car batteries with tethers. I'm looking at ways with Dr. Lang to improve the efficiency. So if you can increase the efficiency 10%, that's the same thing as improving your batteries 10%.
Gotcha.
And you start getting all these efficiencies in every part of the UAV.
And eventually you'll get there.
Eventually we'll get there.
Think back to our last episode when we looked at the structure of butterfly scales with a scanning electron microscope. Any structural or mechanical engineer can tell you that these scales are designed to resist bending in one particular direction. So does that mean that they're actually designed to capture more air with each wing beat? Dr. Lang and Dr. Slagers are actually testing this theory with real data. They put reflectors on the butterflies and fly them in the ATOM lab and record the data of the flight. Then they're able to virtually play back the flights in slow motion. You can do really cool things like measure the wing beats, you can measure the position, the velocity, you can get the kinetic and the potential energy at any one point along the flight to get an average of how hard that butterfly is having to work to move across the room. In the end, they only got 2 good data sets, basically the same butterfly that flew with and without scales. So what do you think the data showed after they removed the scales from the butterfly wings?
So their flapping frequency increased by about 5 to 10% to achieve the same increase in energy. By increase in energy, we meant a combined speed and change in height.
Okay, so what does this mean for science?
So it meant that they were, say, 10% less efficient. They had to try 10% harder by flapping harder to get the same amount of motion out. I'm looking at ways with Dr. Lang to improve the efficiency. So if you can increase the efficiency 10%, that's the same thing as improving your batteries 10%.
Okay, and so what's the application? That we're going to start putting scales on micro air vehicles?
That's exactly what it means.
It's because of research that's going on right now at UAH, right?
Yes.
Thanks.
So if you want to, check out the deep dive and go back through all the stuff we've learned on butterflies together. I mean, we've covered caterpillar locomotion, complicated cocoon designs, how they gather nutrients in order to mate, how they lay eggs. We even covered the incredible optomechanical design associated with their wing scales. I mean, it's pretty cool stuff. There are still several things that we don't know about butterflies. For example, scientists do not know how metamorphosis came to be. It's a pretty crazy thing if you think about it. I mean, this creature that has the ability to eat and sustain himself destroys almost everything about about his old ways and is reborn to live life in a totally new and exciting way. But before he enjoys this new, more productive and fruitful life, he first has to die to himself and then allow himself to be remade.
Okay, there's one other thing that I think you deserve to know. The first sponsored video on Smarter Every Day was the butterfly life cycle video. And your response to that video was so big that Audible decided to sponsor Smarter Every Day for 6 months. And that doesn't sound like a big deal, like in the grand scheme of things, but I want you to know that I really appreciate that, because that was 6 months of uncertainty in my job. I was furloughed at one point, the government shut down at another point, but I had stability for my family and I had peace of mind because you guys were downloading free audiobooks. So it is with great joy that I would recommend to you audible.com/smarter. Go get your free audiobook. You can do whatever you want. There's tons of titles. If you don't like it, you can return it and get a different one. But I just want to say thank you. Thank you to you, and thank you to audible.com for sponsoring Smarter Every Day. It means a lot. Anyway, I'm Destin. You can check out the deep dive if you're interested in that. You can also get your free audiobook. Anyway, I'm Destin. Getting smarter every day. Have a good one.